a chance to get that tweet out.
Yeah, I just asked Shez to do it.
Okay, great. Smart.
That's okay.
Delegate. I tweeted one 6 hours ago. Tweet again. This one's actually. We did our Weave user group too, right?
Yeah.
In general? Which one?
I posted in all of our meetup groups.
Oh, I meant Weave users Slack.
Oh yeah, I did in general, Flux, and Flagger. Tried to cover all the bases. Okay, so if you don't mind, I'm gonna do a little music test.
Yes.
Make sure that I can hear that on YouTube. So hit play. Bring that up.
And you said Kubernetes Slack.
Yeah, I posted in the GitOps Slack. Are you able to hear that music in Zoom at all? You're not, right? Okay. So when I'm playing music, I can only hear it unless you're tuned into the YouTube live channel, because it definitely is coming through on the YouTube live, which is great. All right.
So we are live now, right?
Yeah, we're doing our sound check live now. All right.
Interesting. My YouTube says live in 60 seconds.
Oh, hit the refresh button, and then it'll... I had to do that with mine, too. Sorry you guys can't hear the music, though. That's too bad.
Right, but shouldn't I be able to hear the music on YouTube?
Yes, but it's off now. I turned it off once I sound checked it. I have a little earbud in that has... It's going to my iPad that has the YouTube stream.
All right. Let me tweet about it again.
Do you want me to turn some music on for...
Yes, please do.
All right. I'm going to find the other one. I'm going to turn this one on just at a low volume.
How's your fiber optic, by the way? No. So, is the music playing? Let me- I'll be right back.
When do we start? Yeah.
Yes, I got my earbuds. Excellent. Let's see. Start chatting with people who are on YouTube. See that most people are there now. You guys see me looking to my left. It's because I'm looking at the YouTube channel. Where is everybody down from?
I'm gonna dial the music down.
Oh no, keep it on. Keep it going. Even though I can't hear it. I'll definitely keep the music.
Okay. It's interesting how at our broadcast the other day, there's so many people from Germany, or at least they were the only ones piping up to share where they were from. But I mean, we had people from Belgium and other countries, but a large number of them.
It's shaking. Everything is shaking.
Oh, this time it says it's logged in as me. I think the past times I was logged in as Weaveworks for some reason as a default. All right, so if you've just joined, if you've been to these community specials before, welcome. We use the first 30 minutes to do an AV sound check and audio check and video check. And so we leave it open. These are kind of community events, so we welcome the feedback that people give us because we're trying out different platforms in preparation for an official event that we posted yesterday called GitOps Days, which will be May 20th and 21st. You can check out gitopsdays.com. We have some great speakers, including Kelsey Hightower, Kyle Rockman from Under Armour, you have Javeria Khan from Palo Alto Networks, as well as a good handful that we'll be adding, in fact, in the next 24 hours as we get their photos and such. Excellent, cool. Lewis from Cardiff, Wales. These are nice Wales as well. Pretty cool. And so if this is your first time joining, then welcome. Yes, these are now been kind of publicized, but we're kind of keeping them low key because we're practicing out and ironing out these kinks in preparation for the event. You can see the Weaveworks logo here. That is Stacey Potter, our community manager, who has been really learning up all these different platforms to get us prepared. the face of figuring out different operating systems, right? Different hardware and operating systems to see what works with these different platforms that we have to try out. Yes, we've posted both the Zoom link and the YouTube Live link in the Meetup page, if that's how you found us. We have all of our live events on meetup.com. And if you didn't find us that way, our single source of truth for our variety of events is meetup.com, I think, /Weaveworks. Check. Meetup.com/Weave user group with dashes in between. So that's where we've had them all. Oh, and we have Vincent again. Thanks for joining. It's great seeing you. It's great seeing the repeat visitors. So if any of you, excuse me, know Stefan already, you would be excited that Stefan likes to talk. Stefan usually develops these very deep discussions, so it's almost painful for him to do like a 20-minute talk. So I said, well, we're doing these community specials, why don't you could just go all in. And so we have it bracketed as two different topics with a little bit of a break in between, but if you have lots of questions, we might go for the long haul, even though we'll see how it goes. We do have a little bit of a break in between. So the first half that we'll kick off is the Kubernetes continuous delivery practices that Stefan will talk about. And then if you do already know him, you likely know him from all the great work that he's done here in the developer experience team at Weaveworks, and in particular creating Flagger. And because of that, we've often talked about progressive delivery, which is at this point, I guess, a term that's been around for about a year and is kind of an umbrella term for things like canary deployments, blue-green. So we have a deep dive into progressive delivery that Stefan will be talking about. So, Stacey, it says that, thanks, Vincent. Yes, Vincent says that in Zoom, I guess people are still waiting to join. Which is interesting because we are broadcasting live.
That's crazy. All right, let me check it out.
Yeah, let's make sure the link. It does say register.
Oh, it's the broadcast button wasn't on. Sorry about that.
Yeah, no problem. As some of you may know, we're testing out different platforms. Oh yeah, here comes some people, and I don't know where Zoom is from day to day, but I know some people have asked, what's the what's the security situation with Zoom, and this is obviously during COVID times. At the time for Zoom, people are using them for everything. A lot of people have created accounts, but because of that, we also provide a YouTube option if people want to chat over there. But please, yes, chat with us. Let us know where you're coming from, what your questions are, and yeah, please feel free to chat with each other as well. We're really hoping that not only do you get a chance to meet with Stefan and ask questions, but definitely chat with each other, because people are a wealth of knowledge in a variety of areas, so it's really helpful. Okay, so thanks, Vincent, for letting us know. Now we've got a bunch of people in Zoom as well. So yeah, let me type in. We are in the pre-show period, so we're just making sure that we have AV working well and chatting with you as well. We'd love to hear where you're coming from, and especially if you have questions or things you want to learn. This is obviously for you. So if there's something specific that you'd like to know about, we can make sure that it's either we'll say where it's mentioned in the talk, or obviously try to do our best during the Q&A. Hey, Omer, thanks for joining, and in the chat. Hey. Joining from. And as some of you may know, Stacey and I are in the San Francisco area, and Stefan is in Romania. So we've got a team from, I think, our farthest reaches today. Actually, that's not true. Well, we have Chanwit, who's in Thailand. So I don't know if he's farther from Romania than we are from Romania. So he's even farther. So next time we'll have to do a show with him. Excellent. We've got Vincent on both sides. So, all right. Yeah, we got a couple minutes, so we'll be just getting ready, and yeah, let us know what your questions are. Stefan, how are you doing?
Great. Happy to be here. My first GitOps Days show. Yeah, I think I'll diverge a little from the schedule we proposed. I'm supposed to be talking about continuous delivery and progressive delivery, and we'll still be talking about these two topics. But I also want to share with everyone some experimental things that I've been working on. So it will be less Flagger, more Kubernetes controller runtime stuff today.
Stefan already works insane hours on work stuff and his passionate projects that are in this area. And so this is something you've been very excited about. And so you guys get a special reveal. When did you officially kind of start working on this, and when did you I guess, start thinking about it, which might be weeks earlier?
So I've been thinking about it for a long time, but never got the chance to actually do the experiment. What got me really excited was looking at Kube Builder and the new runtime control runtime release, and I felt like, okay, looks way stable than last time I tried. I'm gonna play around with it, and yeah, I found it very appealing, and I think it's a great framework to, if you know Kubernetes, you can be, I don't know, can do experiments very fast. You can develop things, deploy them, test them in no time. So yeah, I think I started like, let me check GitHub, 25 days ago.
Oh, nice. Excellent. And distributed systems fanboy. Yes, there'll be a recording available, and Lewis is excited for the experimental stuff. So yes, thanks for letting us know. Definitely love to share. I mean, think about the days when Flagger was this experiment that you thought, well, I'll put it out there and see what the response is. And now it's become such a thing, right? We have so many people talking about it. You've gone to conferences, you say, oh, people, I saw 5 people mentioning Flagger or demoing it, and as well as even your sample app, Pod Info, that you use. You say, oh, I noticed people are using that too. So yeah, you never know. And once it's out there, though, it's pretty rewarding to see when something does stick, or it really did kind of hit the mark, right?
Yeah, Flagger was an unexpected, had an unexpected, I don't know, user base at the beginning. And I think it's all due to that talk I did in London at the Istio meetup at Monsell Bank 2 years and something ago. Yeah, I got like excellent feedback after the talk, and I kept working on it, and it turned out okay.
Yeah, and I was chatting with Cornelia Davis, our CTO, and so she's very excited about this experimental project too. So she's excited that you shared it with her and looking into some more thoughts as well. So we're going to start in a couple minutes officially. Unofficially, I noticed that in the chat in Zoom, I did a common problem, which is when I chatted only to all panelists. So when I was asking a question of where people are from, it only went to our panelists. So I retyped it and put it in all panelists and attendees. So for those of you who are joining Zoom, I'll be talking about this in a bit, but just a reminder that when you do go in the chat, make sure you send it to all panelists and attendees so that you can share your questions. And sometimes people share their answers. They won't be able to see it unless it's there. Unless you have something burningly private that you just need to send to us, then otherwise, yeah, make sure that you choose that drop down in Zoom chat. As for YouTube chats, we've got a couple more people now. Where else are people dialing from? We had Cardiff, Wales, and Vincent, I think you were in France. Sorry, forgetting a lot of people from different places, trying to get my brain going here. And hear from our Zoom chat. Oh, excellent, from Munich. That's nice. Get this in here. So speaking of which, I think I've got my earbuds right now in the Zoom, but if you're on the YouTube side, you should be able to hear the music that we're piping right now from London. Cool. From our another community manager here that some of you may know, Daniel Holbach. So if you've come to some of our previous events, then you've seen him DJing live. Thursdays is his non-work day, so he has provided this recording that Stacey has streaming that I'll be able to hear on the YouTube side as soon as we get this broadcast going. Cool, so we got London, Paris, Munich. And then we had Cardiff on the other side. Anywhere else? Do we have anybody from the Americas or from Asia? Oh, another London. Excellent. Oh, cool. Pradeep is asking, I sort of use Flagger. One thing I noticed is it does not create custom metrics to auto-generate HPA. And is asking, are you planning to do anything with that? Melbourne, cool. Oh, in India,
Yeah, so
awesome.
Flagger does not generate metrics, it consumes it. So you can set your horizontal pod autoscaler to consume metrics from whatever providing you are using. I have a repository on GitHub called HPA Istio, and you can look at that, how you can, for example, scale based on request per second metric that Istio reports to Prometheus. So there are many Flagger users that are using scaling, auto scaling based on request per second or latency. So that definitely works, but I don't think it's in something that Flagger could do, something that you have to configure your HPA to do.
Okay, hopefully that helps. I'm trying to find my. Oh, I see. Okay, so Stacey has wound down the music. Cool, excellent. So we are now at the hour. We'll officially get started. So welcome. This is our GitOps Days community special. If this is your first time, then welcome. This is a weekly series that we kicked off about, I think at this point, 3 or 4 weeks ago, where we're planning for a GitOps Days event on May 20th and 21st, which now you can see on gitopsdays.com. And so leading up to that, we thought, well, we've got all these different platforms that we need to practice on. Why don't we just put it out there in a very community way once a week to have Stacey, who's here, Stacey Potter, who's our community manager, test out all these different platforms. And it's not perfect, but we'll put it out there and we'll see what feedback our community can give us. So if you've joined before, thank you so much for joining and being in the chat on either Zoom or YouTube, and both with your questions as well as your feedback on how we're working things out. So if you were here a little bit earlier, our first 30 minutes, hopefully you can see my schedule. I'm trying to point my finger here, is got our little schedule here. And if you're watching on Zoom, you should have the scrolled banner at the bottom, which will show which parts we have. So the first part, yeah, we were doing a sound check, a little bit of chatter. Nice to see where people are from. So thanks for coming in. And we've got people from London, Queens, India, Wales, Bangalore, Melbourne, France, and I think we had Germany, and I hope I didn't miss anybody, but we've got a lot of good different countries here. So yeah, please share with us where you're coming in from. And it seems like we are pretty broadly spread out. So quick thing, my name is Tomo Nakahara. I run the developer experience team at this company called Weaveworks. We've got Stefan Prodan here, who's a developer experience engineer in our team, dialing in from Romania. And we've got Stacey Potter, our community manager, who's making sure everything stays afloat. Stacey and I are in the San Francisco area. So we work for a company called Weaveworks, which is a startup based in San Francisco, New York, Berlin, London, and Colorado, as well as distributed teams. If you've seen us, our website is weave.works. We have done we've created many open source projects. That's often how people know us. Things like WeaveNet, which you use for networking your Kubernetes clusters. Projects such as Flux and Cortex, which are in the CNCF as sandbox projects. Flux is sort of what got us to the concept of GitOps Days. Our CEO, Alexis Richardson, coined it, and it kind of took off. It was sort of an observation of what seemed to be happening in our space. As you may know, Flagger, which is something that Stefan created, as well as many, many more. So if you go to our GitHub page for Weaveworks, you'll see all the projects that we have. We also have two products, Weave Cloud, which is a SaaS product that helps you do automated deployments, monitor clusters and manage them, as well as WKP, which is our Weave Kubernetes platform. So if you're looking for an enterprise level GitOps platform, that is a product that we put out there once we saw that people were interested in that actual layer that we created to put the Weave Cloud product on Kubernetes on AWS at the time. So we've been running Kubernetes in production for 4 years now. And so those are things that you can check out if you're interested in doing GitOps in a variety of ways. So again, thanks for joining us. As I mentioned, if any of you, hey, from Russia, cool. If any of you know Stefan, hopefully you are excited to spend these couple hours with him. He'll be digging deep. As we chatted in the pre-show, we're talking about Kubernetes continuous delivery practices, as well as a deep dive into progressive delivery. But Stefan will diverge a little bit as well, because he's very excited to reveal this experimental project that he's working on that is still relevant to the space. So with that, I will hand it over, and we'll be looking forward to chatting with you guys in the chat.
Thanks, Tamo. Okay, let me share my screen. Okay, so I'll be trying to talk about continuous delivery in the Kubernetes space and give an overview of how things are evolving, or how I see things evolving in the CI/CD space. So let's start with how CI/CD together look like when, let's say, you first try to deploy something on Kubernetes and you don't have like I don't know, tools installed and stuff like that. You just want to say, hey, I want to get my my Docker image on the cluster. So you may have, like, of course, your application repository. It's let's say on GitHub or on GitLab. Maybe you have a CI/CD platform, or you run some open source project like Jenkins. And I don't know, let's say the usual way of deploying stuff is you have a Docker file, you have a bash script that runs Docker build, and you need some Kubernetes manifests in your repo so you can do kubectl apply on those manifests. How this works, your CI/CD platform or builder or whatever it is, you can configure it with a webhook. So every time you do a push to your app repository, the CI job kicks in, builds the image using your scripts. That creates a tarball. That tarball gets pushed to a Docker registry. And afterwards, you need to deploy on Kubernetes. So the easiest way possible to do that is, let's say in your bash script, you have a sed command, and you replace the image tag with the one that you just built, and you apply it on the cluster. Or you can use the latest tag, so you don't have to do any kind of replacements in your YAML. And well, Kubernetes will not actually detect that latest tag because it's not actually a change. But you can do some tricks with, you can tell Kubernetes to always pull your Docker image. And you can do a thing with kubectl called kubectl restart. It's quite new. It will add an annotation to your deployment. Your deployment will restart all the pods. And because you've set that always pull policy, all your Kubernetes nodes will be pulling the latest app. So that's an easy way to get started, right? If you want a container image running on your Kubernetes cluster, you can do all things from a simple script. That script runs, let's say, in your Jenkins pipeline or GitHub action workflow, and this is how you can deploy it. Now, there are a couple of issues with this approach. First of all, if we get back to the idea, I'm going to use latest, I'm pushing latest, and that's the easiest thing to do. One big problem you'll have if your container images have these mutable tags that you overwrite all the time. The fact that, let's say you have a Kubernetes cluster, you have 3 nodes, your app is running on those nodes. Then something happens with one of the nodes and that node restarts. Or another node is created, maybe you are running with preemptible VMs or stuff like that. When the new node is created, the kubelet will re-download that image because, well, it's not there, it's not stored on the node is fresh. And what will happen, it could get a different latest image from your Docker registry. Let's say, meanwhile, you did a CI push. So you'll end up with this state where you have a single replica set that should have the same container image in all these pods, but in fact, you'll have a single replica set with different versions of your app, different versions of the latest tag. So don't do this. Latest is evil. The easiest way to do it with any CI platform out there is you can get the Git SHA. It's very easy to do that in Bash or any kind of script that you are using. Most CI platforms out there offer you an already provisioned environment variable called Git SHA or Git commit. And you can use that SHA when you tag your Docker images. What that ensures, it ensures that your CI job will produce immutable artifacts that you can then deploy on your cluster. And that's so much better with just some simple changes in your script. Now, let's say you are deploying immutable things in your Docker registry, and you are using the best script to replace the, let's say, the latest tag that it's in your manifest file with the one that you've just pushed. So every time the CI kicks in, you replace the tag in the YAML, then you apply it on the cluster, right? That's an easy thing to do. But there are still some problems with this approach. And I've listed some things when you do all things with CI/CD. So your CI platform is also your CD platform, and you do build, push, and deploy from a single job. It's almost impossible to determine what application version is running on your cluster by just looking at your repository. Because if you replace the tag in your CI pipeline, then the version that's deployed, it's somewhere in your CI logs. So you have to look up all the jobs, find the latest job that was running, and look up the Git SHA to determine, okay, what's running in my cluster without actually looking at the cluster and inspect it. So that's one problem. Another big issue is the fact that CI jobs are unpredictable. You run, let's say, the same job twice in parallel, and it will, even if the first job starts, the second one could finish faster than the other one. So the latest job that started for the latest commit is not guaranteed that that one will actually be deployed. Because if if it's faster, let's say it gets a better PM in your Circle CI or whatever platform you are using, then it will finish before the old one. The old one will override the previous deployment and so on. You can do a blocking CI workflow. So maybe you can manage this and block all this and not run things in parallel. But what happens if, let's say, you have an incident and you want to redeploy a particular image? What you can do with such a system is you have to rerun that job. What rerun that job means is you have to rebuild the image, redeploy it on your container registry, then it will apply. But it's not the same thing as reapplying the YAML, because when you have a new image, maybe the code is different. I don't know. You can end up with a different thing. You cannot reproduce the previous deployment easily. Other challenges are about cluster authentication. Like, for example, if you have two-factor enabled, then your CI job cannot connect to the cluster. So you need to open up some security holes. So to say, we have to give the CI job a token that doesn't expire. If someone hacks your CI pipeline, then it can get access to the cluster without two-factor, without anything. And they can do whatever they want, because if your CI is deploying applications, then it has to have the RBAC and service account powerful enough to create all these things, deployment namespaces and all this stuff. So if someone gets that key, they can also replace deployments. So they can run, I don't know, cryptocurrency miner or whatever on your cluster. This type of CI pipeline attack is very frequent nowadays. Other issues here, let's say you start with a cluster, you have this setup. Then you decide, okay, I need more clusters. I need the dev cluster and I need the production cluster. Then you also have to have your production or your second cluster keys in your CI. So the more clusters you add, then you have to manage all these secrets and manage all this authentication, and your CI has to know when to deploy to a certain cluster or not. Of course, you can build all this logic in your bash script. You can say, oh, if it's the production branch that I'm going to deploy to the production cluster and so on. That's one way to solve it. Another issue with having manifests in your app repository is when you have multiple apps that you need to deploy in a cluster. Which one of those apps have the namespace manifest, for example? Which one has the service account? Which one has the cluster role binding? So you have all these, let's say, some infrastructure setup that your application needs. Let's say an ingress controller. You have to install the ingress controller before your app can be exposed outside the cluster. Where you put your ingress controller definition? Maybe you put it everywhere. So every time you deploy one of the apps, the ingress controllers will be overwritten by these jobs. How can you ensure your app deployment doesn't affect another app? If you share things in common, then you probably cannot do that with a CI deployment. And the last challenge, like I think this is the biggest one. How do you recover after a whole cluster meltdown? Let's say your cluster goes down. You use a SAS database so you don't lose your actual data. Let's say you have an RDS or a MongoDB outside of your cluster, and you want to restore your cluster state. Now, how can you do that? You have to know which pipelines, which CI pipelines have all these manifests. You have to figure out the correct order of running them, and you have to rebuild all your image and redeploy everything to get the cluster restored. That's not quite a good strategy for disaster recovery, running all these CI jobs in a certain order. So how can we improve this model? How can we make all these processes better for Kubernetes? The answer is like very simple. We break things out. We break CI from CD. It's not that hard. You can do this. You can say, my CI jobs will end up with a container image push, and that's where the CI platform role ends. It doesn't know about the cluster. It doesn't have the cluster keys or anything. It builds my app, creates the tar, it pushes the tar to the container registry, and then it could do the same stuff with the script, run a sed command, and replace in the manifests the image and commit back that manifest to Git, or commit it to a different branch, or even to a different Git repository. The idea is that the CI platform knows what it has built, and it can persist that information. Instead of just applying it on the cluster, it will just persist that information in the Git repository, or in a different Git repository if you want. That's one way you can limit the CI jobs. Now, what does this give us? Well, if the latest artifact that was created based on a CI job is committed back to Git, then I can look at the Git repository and determine what is supposed to run on my cluster. Well, supposed to run this commit, this container image, and along with all the manifests it needs. So just by doing this, it's a huge improvement, because now you know by looking at your source what should be running on the cluster. Now, how can you promote this change to the cluster is you create a CD pipeline in your CI maybe, or you use a continuous delivery platform that works, let's say, very similar to the CI approach. When the CI commits back the Git SHA to the manifest, you could spin up a new pipeline that's triggered by a webhook. It builds the YAML. Maybe you do some validation of them with kubeval, or you do a customized build, or I don't know, you just make sure your YAML is okay. Then you apply that YAML to all your clusters. It's not much of an improvement, but it's something. We have separate jobs. Now we have in our manifests the desired state of what should be running in your cluster. The CD platform, that's the one that will have all your cluster keys, all your Kubernetes keys. So let's say on your CI job, everybody has access there. All your developers, everything, you can restrict access to the CD job better than to the CI, because less people should have access to that. So maybe your keys are safer there, but this also has a lot of issues. For example, the more clusters you add, you have to modify the CD platform. The CD platform also runs some script or some workflow that has to be in some Git repository, or even in your app repository. So you still have to maintain all these all the deployment logic through scripts or through some, let's say, workflow YAML. Now, one idea would be, instead of running the CD jobs from outside the cluster and deal with cluster connectivity and all that, we can reverse the problem and say, instead of doing all these things from outside, I'm going to do the apply from inside the cluster. What this give us? It give us more security, because if your CD pipelines are running inside the cluster, then they are running on the service account. They don't have to connect to the cluster anymore. You can restrict their access to the cluster with Holbach and service accounts, and you don't have to share the keys outside the cluster for this type of deployment. Now, this approach also lets you scale easily the number of clusters, because the more clusters you add, you'll be deploying, let's say, the thing that bootstraps your cluster also deploys these CD controllers. Then it doesn't matter how many clusters you have, all of them will be looking at the same repository. They'll all fetch the same manifests, and they can apply it. So by just adding one more cluster, that's enough. You don't have to go back to your app repositories and change all the deployment scripts in all your repos. Another thing you could do when you switch to this model of running the CD things from inside the cluster, you can aggregate your manifests under a single repository. And this is something that Weaveworks, we recommend doing it. Our tool FluxCD works in this way. One of the advantages of having everything in a single repository is the fact that you can have this view of your cluster unified. So you have your infrastructure manifest, let's say your ingress controller definitions, your service mesh installers and everything like that, along with your application manifest. So if you put everything in a single repository, by just looking at that repository, you can tell what's running in your cluster, and you can have a very strict control about what changes will be happening in your clusters. If someone makes a change, they will be opening a pull request on the cluster repository, and your, let's say, SRE team will approve that pull request if they feel like that change is okay or not. Now, this also has some drawbacks. Now, instead of each team that develops all these applications, instead of just placing the manifest YAMLs inside the app repositories, now they also have to commit them to the cluster repository. The CI jobs from the apps repository could have write access to some parts of this repository, could open pull requests on that when the commit changes. So it's not that simple to move from this setup to something that runs the CD inside the cluster. You have to perform some changes in a way your teams are working, in a way that they collaborate on delivering software.
Oh, we had a quick question, sorry.
Yeah.
So our friend was asking, do you keep source code and Kubernetes manifests in the same repo? And I was asking, hopefully it seems like you're covering this, but then he kind of followed up and said, what you talked about with CD seems fine, but I was wondering how that works with CI. What does it mean to have source code to be part of the CI? I hope that question makes sense.
So in your app repository, you have here, right? You have a Docker file, you have your Kubernetes manifest, you have your CI scripts or workflow along with your application code, right? So you can build a Docker file through your application, run the unit tests in CI, and so on. What I'm talking about here is removing the manifests that are actually being deployed on your cluster from the app repo or duplicate them and put them in a single repository that everybody uses, everybody shares, let's say in this cluster repository. So what CI will be doing from that moment on is just run your unit tests, build your application, build a container image, push the container image to the container registry, and afterwards do something with that information. While you could commit to the cluster repository, the new commit SHA directly from CI, or some other process could do it. For example, Flux can monitor container registries, sees that, oh, it's a new image, and it will do the commit automatically back to this cluster repository. Other tools just let you approve this process and so on. So how you deliver the desired state to this single repository, there are many options. For example, many people like to do it manually because there is a QA process, manual process that someone says, okay, now this image is all right to go to the production cluster. You can do that with, I don't know, GitOps, Jenkins X. There are so many options out there, but the process is quite the same. That's what I meant. Okay, move over. So what's the role of a continuous delivery controller? His role is not just to apply container images. I think a continuous delivery solution for Kubernetes should be doing reconciliation like every other controller that comes with Kubernetes. For example, the deployment controller reconciles the deployment specification with what's running in your cluster. If in your deployment specification you say, hey, I want 3 replicas of this pod, then the deployment controller will try to make that a reality. Will try to spin up 3 pods. Maybe it fails. It will try again. Maybe you delete a pod. It will react to that and it will recreate it until it reaches that desired state that you specify in your deployment spec. So we can take that idea of what happens with these native Kubernetes controllers and apply it to the continuous delivery controllers and say, the Git repository is the desired state for everything that's running in my cluster, not only the number of pods, but also all the deployments, all the ingress controllers, all the things, horizontal pod autoscaler, everything that sits in a manifest in a Git repository, that's the desired state. And the CD controller, instead of just reacting to things from Git, like a webhook, instead of doing that, it can also do that. But I think it's also important for this continuous delivery controller to reconcile the state of your cluster and, for example, detect drifts. Let's say someone does a kubectl edit on your production cluster and change something. That change is, let's say, an unauthorized change, because all the changes should be traceable, should have a trace somewhere in a Git log or a pull request or something like that, right? So the controller should detect that change and should undo it. If in your Git repository you say, I want this deployment with 3 replicas, and someone goes and does a kubectl edit of the deployment and sets 5 replicas, then the CD operator will have to reapply the 3 replicas and undo that unauthorized change. There are certain type of drifts that cannot be corrected. And in those cases, the controller should let you know, hey, I've detected a drift. I cannot deal with it. It turns out, I know I don't have enough capacity, or there are so many things that can go wrong. It should alert in some way to an outside system, or through Kubernetes events, or I don't know, Slack channel, whatever. But it should be in the continuous delivery system role to detect drifts, try to correct them, and alert on a misconfiguration. So this is something that you cannot achieve through webhooks, and if only you react to a Git commit. Yes, Tama. There's another question.
Yes, we got a couple from Omer on YouTube. And so he's asking, so the suggested way is to use different repos for the YAML manifest files, aside from the source code of the app and Docker file. He says, and actually Flux is creating another repo as far as I know while creating GitOps. So my question would be, do you suggest different repos for different clusters, for dev, test, stage, production, Kubernetes clusters, or a same cluster, but a different directory? And thanks for that question, Omer.
Yeah, it's a question that we get often on the Flux Slack channels. There are many approaches to this. We at Weaveworks, how we do this thing, we have multiple clusters, dev, staging, production. We have a single Git repository with a master branch. And in that master branch, there are directories per environment. So we have a dev directory, a staging directory, a production directory. When someone wants to make a change, let's say in dev, you create a pull request, developer approves it, that gets committed to the master branch, and the Flux that is running on the development cluster watches only the dev directory. It is not aware of the staging and production. So it will synchronize only dev directory, and this is how we promote things. If dev looks okay, then we promote that change to the staging directory and then the production directory. And this works okay for us. Other Flux users are using branches. So you can have a dev branch, a staging branch, a production branch, and you can merge from one branch to another. This is not as easy as it sounds, because for sure you have differences between dev and staging and production. So if you commit something to the dev branch, is not, let's say, merge the dev branch into the staging branch, because there are all these differences. Let's say your ingress host names are different. So you have to do cherry picking and all these things. But some users are doing it and they are happy with this approach. Other approach will be like having a total different Git repository per cluster. And this type of approach is used, let's say, by financial institutions that they don't want to risk anything. So the developers have access to the only to the cluster dev repository, and they have no access to the production repository, where only the SRE team has access there, and they have some automation to create pull requests based on at the end of the sprint, let's say, on the dev branch, on the dev repository, all those changes are made as a pull request on the production repository, and so on. So all these three approaches are supported by Flux or any other GitOps operator out there. It's up to you, and it's up to how your organization is formed. It's all about how your teams are working together and so on. Where was I? Okay, I was talking about cluster reconciliation. Another thing so the idea was that your CD pipeline should not be reactive only. Like, okay, I have a webhook. Every time I do a commit, only then I'm running all these things. the CD pipeline should also monitor what's going on in your cluster and reconcile the state continuously, let's say. Continuously is not actually continuously. Flux does it by default every 5 minutes, for example. You cannot continuously apply those YAMLs because you DDoS the Kubernetes API, but you can set like an interval where the reconciler runs and detects changes and undoes them. Another thing to improve the security, so moving the continuous deployment tools inside your cluster means you don't have to share your keys with your external tools. But then your Git repository, let's say the cluster repository, that becomes the main target of an attacker. Like, okay, I cannot reach the CD system because it's not out there. But if I can get access to the cluster repository, then I can deploy whatever I want on the cluster. How can you defend yourself from such an attack? Git has a way of signing commits with, for example, PGP keys. So each developer can have its own key. Even if someone, let's say, hacks your GitHub account and gains access to your repository, if it does a commit there, it doesn't have the private key to sign the commit. So even if it does a commit, the continuous delivery operator should be able to verify the identity of those that are allowed to create changes in the repository. For example, how this works with Flux, when you install Flux, you can tell it, hey, these are the keys that are that you have to use to verify the identity of the committers. So if someone which is not in that list does a commit, even if it's signed, but is not signed with that specific key, then the operator will error out and will stop applying the changes from that moment on. And of course, it should alert or something like that. So you are aware that someone hacked your repository or someone else's Git account and tries to apply changes on your production cluster. Another thing here that it's often mentioned, when you store your manifest in a cluster repo, then, and if you want to have all your cluster state stored there, you have to put in there secrets, like API keys, database username and passwords, and so on. Yet again, you can use PGP with Mozilla SOAPs, for example, encrypt those secrets, place them in the Git repository, and the controller will have the keys to decrypt it. So the repository can even be public because no one can read those secrets. Only the controller that applies the repository has the right keys to decrypt the secrets before it applies them. That's one solution. Another solution will be to run a different type of operator that's responsible for decrypting those secrets. For example, Bitnami has a controller called Seal Secrets that does that. So it generates a public and a private key. Everybody has the public key. So anyone in organization can create secrets inside the repository. No one can decrypt them. Only the Seal Secret controller that's running on your cluster can do that. Other options are Vault from HashiCorp. I think the Vault controller can do the same things. And there are starting to appear many solutions out there, many controllers that are doing this kind of encryption, decryption for you. So there are many solutions on how you can store secrets safely in Git without sharing them between teams or even between members of the same team. what are the established solutions to do such to build such a continuous delivery pipeline? And I've listed here only the solution under Linux Foundation. So FluxCD, that's the organization name under CNCF Sandbox. There are two projects there. One is Flux that does the Git to cluster reconciliation, and a sub-project of Flux is the Helm operator that can pull Helm charts from Git repositories or from Helm repositories and apply them on your cluster. So these two tools can work together to create the desired state and reconcile your cluster from the desired state, be it with plain Kubernetes YAMLs, be it with customized setups. Flux can run a customized build before applying all this stuff. Or you can use Helm charts to package your applications, and you can have custom resources called Helm releases that can be stored in the Git repository. Flux will synchronize them. Helm operator will detect those Helm releases and will act on them. Like it will do an install or an upgrade or a rollback, depends on how you configure it. And why I've listed Helm operator here under GitOps solutions is because Helm operator can share the SSH key that Flux creates, and you can also store your charts code, your chart code, without the chart being packaged, like the chart definition, the chart YAMLs. You can put those in a Git repository, and Helm operator can connect to that repository, pull the charts, build a chart, and install it. So Helm operator in many ways is a GitOps tool as well. Other options are Argo CD, also in CNCF, and Jenkins X under Linux Foundation, not in CNCF, it's in the Continuous Delivery Foundation. And the container solution, people have published a very nice blog post which does a comparison between all these three tools, and go ahead and read it. It's a nice overview of all the capabilities of each tool, so you can, decide what's best for your company, your setup, and so on. Okay, still have some time. So what are the challenges, even if you use, let's say, a continuous delivery solution that does GitOps, connects the Git repository, and does all these things in a secure and descriptive way? What are the challenges when you use such a solution? Well, the main challenge is the fact that these tools are applying things on your cluster, and that's about it. What happens if the thing that they're applying, the new version of your application, crashes after, let's say, a couple of seconds after the deployment finishes? That's very common. How can you run tests, conformant tests, once the deployment is there? Right? For example, Flux just only looks at YAMLs and applies them. Helm operator does a Helm upgrade, and if the Helm upgrade is successful, that's it. But it can be successful from a point of view that, let's say, the deployment has started. But what happens afterwards? Maybe that application, the new version of the application, even if it's starting, maybe the readiness probe is okay, the liveness probe is okay, but all the users that are actually accessing that application will run into 500 errors, stuff like that. How can you make sure when you use GitOps that you correctly bundle all these modifications? Like with Helm charts, it's kind of easy because when you change a container image, you'll be also changing the configuration it needs. So those two things apply together. But if you use, let's say, customized or plain YAMLs, then a container image change can happen on a different commit than the configuration change. So you have to keep those in sync. It's your responsibility. How can you do rollbacks automatically? It's not quite possible if your delivery tool only applies things, and if the apply works, that's it. Cannot do automatic rollbacks, of course. Can you run multiple versions in parallel? Well, no, because when you apply a new deployment version, Kubernetes will roll it, or it will do a replace depending on what strategy you choose. So if you want to run multiple versions, then you need to duplicate all the YAMLs and maybe have some bash scripts there to orchestrate all that, right? Can you do A/B testing? Well, the answer is no to all of that, because if you are just reconciling the state, it's not in the reconciler responsibility to deal with all these things, right? So what's the solution to improve the deployment, let's say, impact on your actual users? Well, we need to break up things again. What we need to break up here is the deployment from the release. Deployment means, okay, I have these reconciliations tools. They apply the new Kubernetes deployment, but that doesn't actually mean it's a release. Something else can take care of the release and decouple those two. How can this be done? With progressive delivery. The idea of progressive delivery, and here is an example with Flux and Flagger, works like that. You change your deployment spec in your Git repository. Flux will apply it, or Argo, or Jenkins, or whatever you are using. Then something else, in this case, Flagger, detects that, hey, someone changed the deployment. Let's test that change with users. Let's segment the users and test the change on 1% of the users, or on other types of segments, like let's test this change only on internal users, or whatever. It's up to you to decide how to segment the users. But the idea here with progressive delivery is you just don't allow a change to be rolled to everyone to all your users in your production system. You control the way the new version is exposed through some ways, and like many ways of segmenting user, and choose the right segment to do your testing. Tamo, do I have time, or it's a break time?
Yeah. How much more do you have? Double check.
I have 3 or 4 slides more. Then I'm going to talk about the new stuff. Okay.
Yeah, go ahead.
So I'm finishing those? Okay.
Yes, go ahead. As I mentioned, the break was an artificial break in case you needed to leave. But I know you can go straight through.
Yeah. So we got to the progressive delivery part, right? We want to split the deployment from the release process. And let's say the continuous delivery tool, the reconciler, does the deployment, then it gives the release responsibility to something else. How can we do that? We need to have a declarative way of representing releases. We already have that. How do you represent a deployment? That's easy. Kubernetes does that. It gives us this deployment spec where you specify, hey, this is how my deployment should look like. What Flagger does, it expands on that idea, and it extends the Kubernetes API with a new API object, a new API kind called canary. And this, through a canary definition, this is how you can define a release. And instead of the canary to be a copy of the deployment and some other things on top of it, the canary is an addition to the deployment. Inside the canary, you say, hey, I want to run a canary analysis. I want to run the release in a specific way for that deployment. And this looks very much alike with how horizontal pod autoscaler works, or the vertical pod autoscaler, ingress, and other types in Kubernetes, where from one definition, from one manifest, you reference another object. And here the canary can, in Flagger, a canary can reference a deployment or a daemon set. So you can say, hey, I want to define a release process for this deployment with this name. And afterwards, you can define how the release is going to look like. You can define a thing called analysis, a canary analysis, and you can set intervals, thresholds. You can specify what kind of metrics Flagger should you look at to determine if the new release will be working or not. You can have alerts. So you can say, hey, if the release is not working okay, please alert all these teams on Slack, Discord, Rocket. There are many integrations here. And you can also define a thing called webhooks. So Flagger can call into other systems. Those systems can run conformance testing, integration testing, load testing, and report back the result to Flagger. And Flagger, based on that result, will take a decision or not. One example here, for example, Flagger works with Helm, and it can trigger a Helm test before routing any kind of traffic to the new version. So that's like how you could implement conformance testing in your production clusters. Is you tell Flagger, hey, when you detect a new version, run a Helm test for it. If that is successful, only then start to route some traffic to the app. So you can define and add all these gates until the new version is exposed to your users. And even if it's exposed to the users, when they are actually using your app, then it might break. Like most of the bugs are happening with live traffic. And here is where metrics come into play. If you are using a service mesh or an ingress controller, these routers, these proxies will expose HTTP metrics or gRPC metrics on their own. You don't have to change your app. So Flagger can tell if your application, for example, is returning 500 errors. And you can tell Flagger, hey, if the success rate is lower than 99%, so let's say I tolerate 1% of all the requests to return 500 errors. But if it goes lower than that, let's say 2% of all the requests are failures, then the new version is not okay, it's definitely not okay, roll it back. And rollback is very tricky in a GitOps system. What actually rollback will mean is for Flagger to undo the original deployment, right? But if it does that, because the GitOps controller is doing reconciliation, it will override it every time, right? So Flagger will undo it, Flux will come and say, hey, what's that? That version should have been running, and it will reapply it, right? So it will be like this conflict between the two. How the conflict is resolved is the fact that Flagger doesn't expose your actual deployment that sits in your Git repository to your users. It creates a clone from it called -primary. So everything that you define as your desired state is cloned, and the actual deployment is scaled to 0. When you change something in your Git repo, the new deployment is applied, Flagger scales it up, run the tests, and run the analysis, everything is good. Then the promotion, what happened, it clones it and overrides the primary version of it. And then it scales down the original deployment. While scaling down works, because if you don't specify the replica count in your deployment spec and you use an horizontal pod autoscaler to determine the number of replicas, then the horizontal pod autoscaler, if the deployment is scaled to 0, it will not try to scale it up. The horizontal pod autoscaler is smart enough to decide, hey, I'm going to to scale based on CPU usage, requests, whatever, only if the deployment has at least one replica. So Flagger scales it to 0. There is no replica count in the Git repository, so even if Flux, Argo CD, whatever continuously applies it, that's okay to stay to 0. And when it actually changes, then Flagger says, hey, scale to 1, then the horizontal pod autoscaler takes it over from there and scales it to whatever it needs. This is the orchestration that Flagger put in place to work well with GitOps operators. And besides the deployment, it also does a discovery of that deployment dependencies. So let's say your app also has a config map, also has some secrets. If you change something in a config map, you can break your app, right? Like most incidents last year from cloud vendors, for example, from Google, from Amazon, and others, were all due to misconfiguration, not misdeployments. So the deployment was okay. The app that was deployed, let's say the new load balancer or whatever they were deploying, that the code was okay. The problem is the configuration change triggered the cascading failure, and yeah, things go down. So because of that, Flagger treats a container image change in the same way as a config change or a secret change. So if you change something in a config map, and that config map is referenced in your deployment, Flagger will run a canary analysis for it. Any kind of change. It doesn't matter where it is. It's in a secret or a config map or a deployment, or those three things are being monitored. So all the config maps and all the secrets are also cloned. So if you change something in a Git repository, let's say in a config map, Flux will apply it, Flagger will detect that, run the analysis, and if everything works, we'll promote that config map change to the primary config map. So this is how revision and promotion works, coupled with GitOps in a nice way.
Can I jump in with a quick question?
Yeah.
Yeah, I think you covered, but Lewis is just want to double check. When comparing stats, are they being compared to pods that have previously been spun up, or do you spin up a new set of pods, both old and new versions, to compare the stats?
The metrics. All right. So the metrics, the default metrics are looking only at the canary pods. They are by default configured to monitor the new version. So if the new version runs into errors, that's where the threshold applies. It doesn't look at the primary, the old version that's running in your production cluster. It doesn't do a comparison between the two. But also Flagger also supports custom metrics. So if you want to do a canary analysis based on the comparison of the two versions, you can easily do that by writing your own Prometheus query or Datadog query or Stackdriver. No, not Stackdriver, CloudWatch. So these three are currently supported. These three metric providers are currently supported by Flagger. And it's up to you to define your metrics for them. You can do comparison between the two versions, or maybe you want to look at business metrics and decide if the canary is good or not based on something else than just requests and latency, because only those two metrics are very, let's say, raw. You shouldn't be deciding things only based on network metrics. You could, if your application is properly instrumented and if it exposes business metrics, then you should be taking the decisions based on that as well. Okay, this is how Canary release works. We have version 1. The GitOps operator deploys version 2. Flagger detects it, scales it up, and slowly starts to shift traffic towards it. And if everything is okay, then it fully replaces V1 with V2 using the Kubernetes deployment strategy. if you specify a rolling update, or if you specify replace, or whatever is your strategy at the end. Besides canary releases, Flagger also supports all other deployment strategies. So canaries with progressive traffic shifting is supported no matter what the network provider you are using. For example, A/B testing, that should be used for front-end applications that are requiring some kind of session affinity. And the explanation for this is very easy. Why a canary release with progressive traffic shifting doesn't quite work for web apps that have interfaces, web interfaces. Now, progressive traffic shifting means that a percentage of your traffic goes to a version or another. But that's based on an HTTP request. Now, a client using a browser or a phone will make several requests to get the JavaScript, to get the HTML, and then the JavaScript will make API calls. So what happens if you do progressive traffic shifting for this kind of apps? You could get the HTML for version 1, the JavaScript for version 2. And the API calls will go version 1, version 2, based on how the proxy decides to load balance all these requests. So you can imagine it's not something that could be useful. So you need session affinity. And session affinity can be achieved in 2 ways, using HTTP headers and or cookies. So you can configure Flagger to say, hey, if there is this HTTP header, with all the requests with this HTTP header, only those will go to the new version. So you can segment your users. You can assign roles to them. Or you can use headers that are injected by other providers. For example, Cloudflare will inject something like the location. So you can say, hey, I want to test the new version only on Romanians. I don't know, stuff like that. Also, you could use the name of the type of the device or the browser. You could target, for example, only Android users, or only mobile users, or only, I don't know, some browser, only Safari users, and so on, because you have every request contains the user agent string, and based on that, with regex, you can split traffic, basically. Or you can do custom things with cookies, of course. Flagger also supports blue-green with traffic mirroring. How this works, all the requests that are going to your old version, to the production release, are duplicated, and they are also sent to the canary release, to the new version. But the request is not forwarded back to the user. So it's a safe way to test your app, because even if those requests are failing, the user will never be impacted. It will get responses only from the old version. Of course, traffic mirroring doesn't work for apps that are that expose APIs that are not idempotent. So let's say if you have an application that does payments, the user will pay twice, basically. So this works pretty well. The traffic mirroring works pretty well for things like machine learning, for things like caching, image processing, all this stuff that are idempotent. Any kind of read request should be fine for traffic mirroring. And last but not least is the classic blue-green deployment with traffic switching. Not everybody does microservices. Not everybody can afford to rewrite their applications so they are stateful and REST and or gRPC and nice. So for legacy app or stateful apps, you could still use Flagger and implement the blue-green strategy, where you duplicate everything. you run your integration tests, load tests, conformant tests, and everything is okay, Flagger will do the promotion for you.
Cool. Do you mind if we jump in with a question?
That's it.
Do you mind if we jump in with a question? Oops,
sure.
Sorry. Yeah, so we got Prageeth on YouTube. So I was asking about when he does cloning, or Flagger creates dash primary deployment. So the old metrics that he had defined based on the original deployment would no longer be valid. Is that correct? So you'd have to recreate, I believe, the metrics. And then asked HPA based on Flagger generated deployments. With that, what is the expected behavior? Sorry, I hope I didn't butcher here. I'm just trying to read. Does that question make sense?
Yeah. Let me go to Flagger docs. Okay, so when you define custom metrics, for example, here, let's say you want to write a metric for something else that Flagger doesn't support, for example, I don't know, 404 errors. You can define a query, and Flagger will replace all these things for you: the target, the namespace, the interval, and so on. So even if the deployment is named minus primary, that doesn't mean your metrics are not working. I mean, why wouldn't they work? Well, of course, if you, I don't know, if you hardcode the pod name, then yes, to not work because it's a different pod name. But if you use, let's say in Prometheus, regex matches and you use the name of the original deployment, then of course your metrics will work. And you can also differentiate between the two on your own. One has primary, one doesn't. So I haven't heard till now from Flagger users that metrics don't work. Also, Flagger comes with a Grafana dashboard, so and you can see in that Grafana dashboard the comparison between the two versions. So have there examples how you can, let's say, modify your dashboards if you need to do that to include the primary. How it can be done is through a regex, and I think I have it here. Yeah, I'm going to find it. So you can define a regex to take into account the primary prefix in Prometheus. So should be a very light change on your dashboard if that's what you think it's impacted. As for the HPA, I'm going to show you how an HPA looks without having to hardcode anything. I'm searching in the wrong. Okay. Yeah, so you can do things like that. And then it will work. And it will scale okay. It's just you define in your horizontal pod autoscaler the a wildcard for the pod name, and that's it. Also, if you use, for example, I have another example here. So if you use the Prometheus metrics adapter, when you define the metric here, so this is how the HPA looks. Right, Flagger automatically changes this. So when it creates the primary horizontal pod autoscaler, it points that autoscaler to the primary deployment. Then when you define the metric, type pods, the metric name HTTP requests. You don't have to hardcode here or put in here the actual name of the deployment, because the horizontal pod autoscaler looks up the deployment name from the target ref, and Flagger changes that. So Flagger will create podinfo.primary with HTTP request 10. And this is how you can easily scale your primary deployments without having to change anything. Flagger does the change for you when it does the cloning. I hope I answered.
Cool. Well, I think that wraps up that first section. We went a bit over and kind of covered, we went a little loose today, covered a bit of the second topic. So would you like to just go into it, or would you like to take like a 3-minute break?
I will take the break. And afterwards,
for fresh air, right?
Yeah. And afterwards, I'll not be talking about old things. I'll be talking about experiments and new things around GitOps.
So if you join a little bit later, I hope it's okay. I know we had printed a schedule, but we're going to go a little bit off topic because Stefan's very excited about an experimental project that he's working on and would love to share. So we'll take a bit of a very, very brief break for Stefan to get some fresh air. And if Stacey, hopefully you're here, we'll roll some of Daniel Holbach's music in the background.
I will bring it up now. Give me cool. Just a second here.
Sure. And yeah, we've seen some new people, so we'd love to hear if you haven't chimed in yet, where you're dialing in from. And also, yeah, this event is for you. So if there are any other things, topics around GitOps, any questions, any lack of clarity, let us know. This is a community special that we've been doing now for a couple weeks, once a week. Leading up to this GitOps Days event that we officially posted. We had a quick turnaround. So it's on May 20th and 21st, called GitOps Days. We're very excited that we have a lot of great speakers such as Kelsey Hightower, Kyle Rockman from Under Armour, Javaria Khan from Palo Alto Networks, Cornelia Davis, our CTO here at Weaveworks, as well as many others that will be posting within the next 24 hours. We're just finalizing last details of speakers, and we'll have a few more that we add. So please mark your calendar for May 20th and 21st. So for this first event, we will be bracketing it for kind of the Americas timeframe. So it'll be West Coast time, 9 a.m. to about 3 p.m. But we will be bringing it to other time zones in the future. So stay tuned, and of course it will be recorded. And so with that, so yes, so thanks for some of the people who have joined from different time zones today. And yes, it's very late for me. Thanks for staying at 1:15. This was one of our earlier times. We started at 6:30 in the morning, California time, for hopefully people who can work. But yes, we will also work for different time zones. And we have some questions here in the chat regarding Flux. So hopefully it looks like Lee Capilli, who's also a developer experience engineer, is chatting with someone in our Zoom chat about some questions about Flux. We can share that on our YouTube chat as well later if you find the information useful. And, so we'll take just a couple minutes, maybe like 2 more minutes, and we'll be back. So see you in a bit.
Outside the liquor storefront, roped up. If it goes down low, homie, don't choke up. Pull out, let them all go. Let the go bust. Innocent bystanders, so what? That's how they thinking around here. Niggas ain't thinking around here. You get dropped at the drop of a dime or a blink round here. And the club don't spill your drink round here. All the niggas sneaks, niggas don't think round here. Pop it up, pop the trunk, pop the out here, no fear, no way. Back to the mall on the stereo play. Back in the place, where you might feel a ball. It's the beauty and the ugly of it all.
Hello, I'm back. Oops.
Yep.
I didn't mean to turn off my camera. I was going to, I guess, choose my generic background because you're going to go off script a little bit. Well, thank you. If you're just joining, apologies for the people on Zoom who can't hear the music that is piped directly to the people on YouTube. So hopefully if you're on YouTube, you could enjoy the music by Daniel Holbach, one of our community managers on the team, who sent us a recording because it's his day off. So let me double check the schedule. So we've got basically 40 minutes until the end of this session. And as we shared in the beginning, we're going to go a little off script because Stefan's very excited to share this recent experiment that he's been working on. We also do have Lee Capilli here, another developer experience engineer in the background who's kindly been hanging out and helping answer some questions in our Zoom chat. And we shared a few to the YouTube audience as well. So with that, I know Stefan will have a lot to say, so I will hand it over.
Okay. So bear in mind, what I'm going to show you now is it's an experiment. It's not something that you should be deploying on your production cluster yet. It's a composition of Kubernetes controllers that you can use together, pick and choose from them, and with them you can define continuous delivery pipelines. At least that's the goal. So what is the GitOps toolkit? It's made out of APIs, and these are not APIs that you directly access through a HTTP or gRPC endpoint. These APIs are Kubernetes APIs, so you'll be accessing them through the Kubernetes API itself. And each tool in the toolkit is built with Kubernetes controller runtime using the excellent KubeBuilder bootstrapping. Is it correctly to say bootstrapping tool? Yeah, KubeBuilder is an awesome tool that puts together all these controller runtime libraries so you can easily create controllers. It also gives you the possibility to create webhooks and other wonderful things that you need to do just to run a hello world in a Kubernetes controller. So I've been working on Kubernetes controllers for a long time now, and I've been going through all the stages of building one. Let's say the first one I built was just with client Go on its own. And it's can be a painful experience, let's say. You have to maintain all these things. You have to do code gen on your own. You have to generate all this code, everything. If something changes, you have to regenerate it. If the Kubernetes version changes it, then if they move some library from one library or move some API from one library to another, then you have to regenerate everything and so on. So I've been having my issues with dependency management and everything, building controls, and KubeBuilder simplifies, and KubeBuilder is a wrapper over the controller runtime libraries, and those libraries are, in my opinion, a sane way of building automation on top of Kubernetes. So I've been playing around the last month with all these runtime libraries to build a composable toolkit out of controllers and APIs that someone could use to define continuous delivery pipelines on their cluster. So what the toolkit will could do are a couple of things. It should be able to manage sources. And what's a source? A source can be a Git repository, a Helm repository, and so on. Could even be an S3 bucket or whatever. It's something that provides other controllers manifests. Also, the toolkit should have the capability of generating manifests, because in a Git repository, you may have, let's say, bases and customized overlays. So the controller should be able to build those. Or you may have maybe JavaScript code. Maybe you use JQ config and you write your Kubernetes objects in JavaScript. So the controller should be able to transform whatever you are defining there, or JSON it, or there are so many things out there that can generate manifests in the end. So the controller should be able to understand how to do the manifest generation and actually do it. Another important part of the toolkit should be manifest validation. Like, okay, you are generating these manifests, but before applying them on the cluster, maybe something is not okay with them. So because all these operators are running inside the cluster, they can use the shiny new things in Kubernetes, for example, server-side dry runs, and I'll talk about that later on. Some guideline on how the controllers that make up the toolkit should work. They should do reconciliation on a schedule, of course, and a user should be able to specify that schedule. Let's say every 5 minutes, every 1 minute, every whatever interval, reconcile the state. But it should also react to events and bypass the schedule timer if it's needed. An important part of the reconciliation should also be role-based access control for these reconcilers. So let's say if multiple teams are collaborating on a cluster to deliver an application and each team owns some microservices, then we should have a way, we as, let's say, the cluster admins, the SRE team that's in charge of everything, should have a way to restrict the access of each team on the cluster scope. So maybe a team should not be able to delete or modify objects from other namespaces that they don't own, or you shouldn't be able to modify cluster level objects like delete a CRD or define cluster roles themselves. So role-based access should be there without creating a new layer of RBAC on top of what Kubernetes does. Being a Kubernetes controller, that means you could subscribe to the native role-based access and use that to enforce these things. Another scope of some components of the toolkit will be health assessment. Like I said before, okay, you are applying something, but what if that something doesn't work? So a controller should be able to do this health assessment. Maybe not as advanced as how Flagger does it with metrics and everything, but it should be able to do health checking, readiness checks, liveness checks, and all this stuff, like to ensure some kind of to ensure that the deployment was rolled out, not the release, but the deployment was rolled out. So that's the health assessment part. Another scope will be, of course, alerting to external systems, and not only Kubernetes events. If, I don't know, an apply failed, something failed, it should let you know on, let's say, Slack or Discord or other systems. And you should also be able to funnel events from outside the cluster into the controllers and, let's say, trigger reconciliation based on external events. And you could have webhook receivers defined and make those controllers react to them. So for the source management, how we can do source management from inside the cluster, how I envision this working is through a dedicated controller that only does source management. And it has a couple of roles that should perform. It should be able to authenticate to a source, let's say using SSH or using HTTPS with tokens, basic auth, and all these type of authentications that a source may require. It should, of course, you should be able to trigger a source sync or run this source synchronization on a schedule. The source controller should be also able to validate the authenticity of the source changes with PGP keys and stuff like that. And its end goal is to create this interface inside the cluster where all these sources are transformed into something that any other controller can consume. And the name of that is an artifact. An artifact is a collection of manifests, being raw manifests or JavaScript or whatever. But all the other controllers shouldn't be aware of where those manifests are coming from. The source controller, that's the one responsible to acquire all these manifests, package them in a way that everybody understands, and the package mechanism is a tarball. And the source controller has two responsibilities. One is to package those artifacts, and second responsibility is to notify all the interest parties that, hey, I have a new artifact for you. It's a new revision, it's a new Git commit, it's a new Helm chart version, or whatever the source controller is fetching. So all these reconcilers that are consuming things from the source controller, they should be able to subscribe to these events instead of them going and looking if something changed or not. So How this works today, the dotted lines are not implemented, are in the specification, but are not implemented yet. So the source controller connects to Git repositories, no matter the Git provider, can connect to Helm repositories, and I don't know, probably S3 buckets if someone wants to implement that. It can also, you can also configure the source controller to with a receiver custom resource and tell source controller to watch for events from GitHub and GitLab and other providers. It produces these artifacts, and all the consumers of the sources can subscribe to Kubernetes API events and detect, okay, there are new artifacts, I have to do something with them. And how you control the sources, right now there are two custom resources. One, you can define Git repositories, and the second one, you can define Helm repositories. Now we have, so let's say we have the source controller that abstracts away all these sources inside our cluster and presents these artifacts inside and only inside the cluster, inside the namespace. There is a network policy there that protects the artifacts from being exposed to other namespaces. Only in the namespace where source controller is deployed, only there you can access the artifacts. And in there, you can deploy other controllers that have the role of consuming those artifacts. And we can have these specialized reconcilers. We can have a controller that knows about customize, for example. So it will know how to build customizations, how to sort them, how to validate them, call out to gatekeeper, for example, to see if the whatever customized build result is valid. We can have a Helm controller, right, that reacts to artifacts of type Helm charts. And we can have any other controller that does this special thing based on some source. And there is a API package, a Go API package in the source controller repository that any other controller can use and subscribe to events and deal with acquire artifacts and deal with them. And of course, it's a package to be used by a controller runtime system. How cluster management will look like in this space under the toolkit. So the source controller fetches all these things. Then let's say we have a customized controller that subscribe to sources that expose customizations. And the customized controller can create this idea of a tenant. And the tenant idea is very loose. You define a tenant based on how your company is, what your company is providing. Maybe, let's say your SRE team provides Kubernetes as a service to all the other teams. So a tenant here will be each team that has to consume the Kubernetes service. Or maybe you are a cloud provider and the tenant is an actual user that shares, let's say, a cluster or a group of clusters. And inside, the result of a customized build can contain Helm releases, right? So Helm controller will look that up. Okay, it's a Helm release. What chart does it reference? It asks the source controller, gets the chart, and does its thing, like Helm operator does today. So this is how cluster management could look like. How is it different from what I've talked before? Is the fact that the cluster state, or the, let's say, the group of clusters, that state can be defined from multiple sources that are not coupled with the actual thing that applies. So you can compose sources from different things, and then you can define tenants that can reference those sources or a single source. It's up to you how you want to build the cluster itself. And of course, the A source controller could, for example, look up a cluster API, Git repository where the cluster API definition, it can reconcile the cluster itself and so on. Everything that fits in a Kubernetes custom resource is a good fit for a source and can be packaged as an artifact inside the cluster. A little bit on the customized controller, what customized controller can do, can reconcile the cluster state from multiple sources because it doesn't quite care about sources. They come from, they are provided by the source controller. Can generate manifests with customized, or can generate manifests from, let's say, plain YAMLs using customized create and the customized build, all this stuff. So you don't have to actually use customized when you build your repository. It's an implementation detail of a controller because it uses the customized libraries to order things, to validate and build them. Afterwards, the controller validates the build, the manifest that resulted after the build with Kubernetes API. It can do server-side dry run. What that means, let's say you have a Kubernetes service definition, and in the service type, you make a mistake, and instead of, let's say, a load balancer, you say load balancers. Now, a dry run, a client-side dry run will not detect that. The YAML looks okay, everything is okay, and it will crash on the apply when you actually do the apply. When you run a Kubernetes server-side dry run, then you'll get back the response. Load balancers is not supported. Only load balancer, node port, and cluster IP is supported. And that kind of error, the customized controller will post it on Slack or Discord, for example. It will not get to the apply part because the validation phase. Other things that it can impersonate service accounts. So you have a single controller instance, but for a particular customization, say, hey, this apply has to be run under this service account. So that's how you can enable multi-tenancy and have define a role-based access for all your tenants, even if you run a single instance of the customized controller. And it can do many other things. It can do health assessments of the workloads. It can run all these components in a specific order using a dependency tree. So you can say, I want to have Istio installed first. The webhook should be healthy until I can deploy my app in that namespace. Or you can say, I want the backend app to be running first, then the database, then the front-end app. So the front-end app can depend on, let's say, Istio, backend, and database. So it's a dependency tree that the controller builds and runs all these things in that order. And it doesn't only run them at Bootstrap, it runs like that all the time. So even if you change something, it will do this ordering based on the relationship. It also does garbage collection without calling out to the Kubernetes API. The garbage collection is the collection marking is being done offline. So you don't need a cluster role binding to purge things. So it works in the multi-tenancy idea, and it can run. It can notify on any change on Slack and Discord. This is how it looks. There is a customization YAML where you can define all these things. This is a pipeline that it runs. It builds, validates, applies, does the health checks, pushes notifications. Multi-tenancy is defined through depends on relationships. So let's say an admin creates a customization that contains namespaces, the tenant role-based access, the tenant service account. And then when you actually deploy something from a tenant Git repository, you can specify all those applies will be running under that service account. And how you do that in the customization, you say, hey, this is the service account, this is the namespace where the service account is, run it under that service account. It's quite straightforward. Now, when you have all these controllers with all these APIs, it starts to look like Istio. It's like very hard. You'll have like so many custom resources you have to understand and be very careful when you write all these YAMLs. So to make these things smoothly, I've written a command line utility that does the validation for you and creates all these Kubernetes objects for you. It doesn't, what it does is, in the end, it will do a kubectl apply. But how you create all these things, it's is through CLI commands instead of writing many YAMLs. And I still have time, right, Tamu?
Yep, 15 minutes.
Okay. I'm gonna try to demo this to you.
Sorry, is
what?
Is TK Tanka?
No, TK comes from toolkit.
Toolkit.
It's toolkit. So I have a cluster, preemptive nodes, so it's not expensive. Let's look, should be empty. Okay, is nothing on it, just the standard namespaces. So I have the TK command. You can download it from GitHub. And what you can do with it. First, you can say, I want to do check.
Can you increase the font size a little? Is that possible?
Is it better or? No?
It's pretty small.
More? No?
Yeah, checking with Lewis who asked, and I also, yeah, I think the left side, yeah, let's try.
So first, what I can do, I can validate my local environment and my remote environment, my Kubernetes cluster. So TK needs kubectl being configured correctly on your machine, and you should be having the Kubernetes cluster. And I can do check for prerequisites. And what it does, it checks that I have the SSH utilities installed on my machine, that I have the specific versions of kubectl customized and Kubernetes API. Because it uses new things, you'll need kubectl 1.18, but you can have a Kubernetes cluster 1.14. And soon we'll get rid of the SSH dependencies because we can write all these things with Go. Just didn't have the time to do it. Hide is doing that. Okay, so I have all the prerequisites. Now I want to install the toolkit components, and I can do tk install, and I'm going to say version master. I'm going to take the latest version. You can also do semver here. You can choose what components to install and so on. I'll just install them all because there are only 2 components right now. What it does now, it compiles it does a customized build of the manifest, goes through all the repositories where all these controllers are, looks up the latest version and bundles them locally. And now it has deployed them on my cluster and has installed them. And now it verifies the install if everything works okay. This is inspired a lot by Linkerd, how Linkerd install works and everything. It's not that shiny, doesn't look that good as Linkerd, but I got the inspiration from there. Okay, so the install is over. The CRDs are okay, the controllers are up and running. I have 2 controllers, the source one and the customized one. Now I can create a source Does it look okay, Tamo? Can you see it?
Yeah, it looks good to me.
Can you see the command?
Yes.
So I'm defining a source using a repository. So this is my app, my demo app, and I have a bunch of manifests in there, plain manifests, customized manifests, Helm charts, all sorts of things. But the idea is I want to register my application repository as a source inside my cluster. And because this is a public repository, I don't have to configure tokens or SSH key or anything like that. When I've created that source, what happened was that the source controller detected, oh, someone wants me to fetch that Git repository, it fetched the repository, and then it reports what revision it took from GitHub. So it took the master branch at this commit. Now, let's say I want to use this Git repository, the master branch, for my dev environment, but I also want to do deployments through Semver of my application. So how can I do that? I can create a new source, but instead of using a branch as a reference, I'm using a Semver expression that will look at the Git tags pushed in my app repository. And I'm going to say, I want to get the latest Semver release that matches this range, greater than 3.3, less than 3.30. So you can do a lot of things here with the Semver range. And let's assume this is a private Git repository. Maybe it's not even on GitHub. So I'm going to use SSH as transport. And I'm also setting here at what interval the source controller should try to fetch, should check for new releases and should fetch automatically the new tag if one is available. So when I apply this, the TK will look up the Git server, generates the host keys, generates a deployment key for me, and asks me to add this deployment key to my repository. I'm going to GitHub. Settings, deploy keys, going to add this deploy key. No write access needed because source controller never writes back to Git, it's only read only. Okay, I've added this deploy key. Now I'm going to tell TK, yes, I've added, check it out. And what it does, it creates secrets for me on the cluster with the host keys, with the SSH private keys, it generates, and also the public key. And then source controller detects all of those and reconciles the thing in my cluster. And this time it fetched the latest Semver that matches the range I set here and said fetch revision 3.3. And this is the Git shard that matches that exact Git tag. So, okay, now I have all these sources on my cluster. How a source looks like, you can do tk get sources of type Git because there are other kinds of sources like Helm repositories and so on. And I can say all okay. Sorry, run it again. So when I get the sources, it tells me which sources are present on my cluster, the revision, and commit. And I can also do, if I want to see how the actual YAMLs are looking like, I can do export sources git, no, export source git minus all So this is what TK has created. It's created these custom resources of type Git repository with all these things that I've said there. So you can use kubectl apply on those YAMLs. You can put these YAMLs in a Git repository if you want. So it's Git also the way. Okay, so I have all these sources. Now, what can I do with these sources? I can look up specific paths inside those sources and reconcile the objects that are declared there. So I can do, for example, I can create a customization for a path. It's in deployment web app common. So here in the common directory, I have namespaces, I have role-based access, definition, cluster role bindings, and other things. So this is something that instead of coming from my app repository, could come from the cluster admin repository or some repository that's owned by the SREs, the people in charge of the cluster. So I'm creating this customization and I'm saying, hey, every 5 minutes, reconcile this directory, enable garbage collection. So if I'm removing a cluster role, I'm adding another cluster role, all these operations will be done for me inside the cluster. And I want to do a client-side validation before applying them. I can also do a server-side validation. Okay, and this is applied on my cluster now. If I'm doing get namespaces, I have the web app namespace created. And if I'm doing web app get service accounts, it also created the web app service account for my application and a reconciler service account, so I can do impersonation for the team that's in charge of the web app repository. Okay, now I have the common things. Let's say could be an Istio definition or Linkerd or whatever, right? Now I want to deploy a part of my application. Let's say this repository is a monorepo. I have multiple microservices inside that repository, and they have all sorts of dependencies between them. What I can say is, I can say, hey, create the backend, web app backend customization. And all these manifests, before they are reconciled, make sure that common is there on the cluster applied. So I'm saying backend depends on this other thing that I've previously created. And I don't trust the web app source enough to give it a cluster admin role. So run this so the reconciler, when it creates the backend app, should be running under this service name and under this namespace. And I'm saying web app latest, I'm giving the path to the backend where my backend definitions are. And another thing I'm defining here, I'm defining a health check, and I'm saying, after you apply it, please check if the deployment backend in that namespace is healthy or not. If it's not, report it back to me and mark this customization as a failed apply. It's been generated, it's been applied on the cluster, and now TK, what is doing is looking at the status sub-resource of the customization custom resource and waits for a special condition, the readiness condition, to become true or not. And it's ready, and this is the revision that has been applied. So now if I'm looking at the web app namespace, and I'm getting the deployments, I can see it's a deployment up and running and is ready. Great. Now let's say I want to deploy a new another microservice part of the web app, and I'm going to add 2 dependencies to it. So I'm defining the front end things that can be deployments, whatever. It's not about applications, it's about parts of how I'm constructing my cluster. And I'm saying, okay, in order to deploy front end, I want common to be there and I want backend to be healthy. Why? Because if I'm defining a health check on backend, then for this customization to run, it looks up all the dependencies health status. And I'm specifying the source, I'm specifying the path again, and I also defining a health check for this part of my cluster. And I'm applying this, and now what the controller will be doing, looks up common, is there, okay, has a health check, no. It looks up backend, is there, okay, is the health status up? Yes, it is, then it will apply it. Or maybe not. Okay, it worked. So if I'm getting the deployments now, then I have the deployments. Now I can say, let's say I have an incident on my cluster. Something is wrong with my web app. And if I'm going to get in there, get dirty, doing kubectl edit, execs, and all this stuff, then I'll be fighting the reconciler, right? Because if I'm editing something to debug it, to do something with it, then all these changes will be undone by the controller. How you can do that today with Flux and other reconcilers is just, okay, you shut down the reconciler while we are dealing with the incident. With the toolkit components, you can, instead of shutting them down, you can suspend a particular reconciliation loop. So you can do tk suspend customization, and I'm going to suspend the front-end customization. So what happens now? I can edit the front end. I can do whatever I want with it. The controller will never try to override it or stuff like that. When I'm done with the incident and I have a resolution, that resolution will end up in my Git repository, right? I'll probably make some modifications to the YAML or whatever, or I'll be trying to deploy a new version, and I'll set that image tag, let's say, in the Git repo. So after I'm doing that, I can do resume. And on resume, the controller will check for a new source. If it's a new revision there, will fetch that revision from the source controller and will apply it. I can also do things like, I can do synchronizations based on events. So I can do tk sync customization, and I will say with source. And this will look up the customization dependencies, the sources, and it will ping all of those. We'll wait for them to pull the changes and then apply it. Yeah, of course. Let's say front end.
Just checking in, we're now 2 minutes over.
Yeah, so the sync command, it doesn't actually call into all these controllers. What it does, it sets a status on the custom resource, then all these things happen in the defined order that you just specified with dependencies and everything. The source controller fetch a new version, it will trigger customizations because it's an event, oh, a new version has come. So all those customizations will be reconciled, and it will be reconciled in the order of the dependency. So let's say I'm doing an upgrade on Istio, and well, when you upgrade Istio, you also need to restart your apps because the new Envoy version, it's injected in all your apps, right? Now, you can get these dependencies and you say, hey, if I'm updating Istio, try to reapply all these applications, and pods will spin up and so on, and you get new envoys. If you add, for example, something like a new annotation or a new label, you can actually trigger through dependencies all these chains of events inside your cluster. And yeah, it's a take it as it is, as an experiment. There are many ideas that could be implemented in this. Garbage collection with service accounts was a real challenge. Next, we'll be building the dependency tree and deal better with dependencies. I don't know where this will go, or it will just be, I don't know, failed experiment and that's it. But yeah, it's the controller runtime tools gives you this possibility of chaining events very easily, subscribing to events, and have reactive systems that also do reconciliation on the same time. So this is just an example of what you can build with the new generation of Kubernetes controller. Thanks. Any questions?
Thank you. And thanks for staying a little over time. Could you share again, are there any links? What are first steps that people can take if they want to follow up or tell their friends?
Yes. So there are 3 repositories. One is the toolkit CLI that has all the things to build a toolkit. And there are different repositories for source controller and customized controller. We went through an exercise of developing all of those based on RFCs and specification and documentation. So you'll find in all these repositories, for example, there is a docs spec. Inside the spec, you can see the design, examples, motivation, why this could be a good idea or not. And then also the API is documented. So you have here all the types in Kubernetes and the behavior of each field, what it does, how it does it, when it does it, and so on. So there is more documentation than code. I think that's
well,
good.
Thank you so much.
Really nice. Yeah.
Yes, thanks for joining, Lee. Yes, Lee was very excited in the chat. Well, with that, thanks everybody for staying overtime. And if you came right at the beginning, thanks for staying for our very long show. And yep, if you have any feedback, please let us know, whether about the content or the platform. Those of you who've joined by Zoom will get an email with these links and other information for future events. If you joined by YouTube, we have GitOps at Weave.works. That'll just kind of come to me, and I'm happy to follow up and give you any additional information you need. We also have a Slack channel, so that'll be included in the email as well, so you can join. So thanks everyone, and thanks for your thanks. It's really great to see you. And as I mentioned, GitOpsDays.com. We just went live with it May 20th and 21st. If you can join in your time zone, we're happy to see you there. Thanks again, Stefan. Thank you, Stacey.